and just some of the properties and things that we need to know about these different groups and families. Forgive my voice, I'm coming down with a cold. So the first thing I want to talk to you guys about are the two ways that we classify the rows and the columns. The rows are called periods, and the columns are called groups and families. That's just really basic stuff. You need to be able to know that. So if I say group 1, we're talking about the very first column going from left to right. Period 1 would be the first one top down. The other thing that you need to know is that the periodic table is arranged by atomic number. So it goes across and down from top to bottom, periodic number. So number of protons. Another word is periodicity, which is a tendency to occur at intervals. So things like the seasons, the moon phases, and the tides are all periodic. They occur at a regular interval. And the properties on the periodic table are the same way they occur at regular intervals as well. This is one way that we color code the table. If you would like to color code your table, I have slides in here that you can access or pause the video to see which groups are color coded. So these groups right here in the blue are the alkali metals. The alkali metals are the first group, and they are very, very reactive. There's a video on my YouTube channel of me demonstrating the reactivity of these metals. They are never found alone in nature just because they are so reactive. They react with water vapor even. They have one valence electron and one oxidation state. These ones in purple are the alkali earth metals. They are in group 2. They are still very reactive, but not nearly as reactive as the alkali metals. There's a video of me demonstrating the reactivity of magnesium by lighting it on fire as well. These ones are found in nature, though they are fairly rare. They have 2 valence electrons and an oxidation state of +2. These big chunk of green here is the transition metals. And the transition metals are the central block. They are very, very stable, or at least they tend to be. And they conduct electricity very, very well. They have valence electrons that act kind of strange. I'm not going to make you guys memorize the valence electrons, nor am I going to talk about the oxidation numbers at this time. Next, we have the metalloids highlighted here in yellow. Some scientists disagree about these final few, polonium and tellurium. I classify them as metalloids personally. They are midway between a metal and a non-metal. They run diagonally across several groups, and they have more brittleness than metals. So if you were to take silicon and smash it with a hammer, it would shatter, whereas if you did that with gold, it would kind of just squish. They are semiconductors, meaning that they do conduct electricity, but not very well. Non-metals I have highlighted here in orange. The main thing about non-metals is that they just don't have metallic properties, and they are across various groups, so they have various oxidation states and valence electrons. Not last yet, but close to last, we have the halogens highlighted in red, including fluorine, which is hiding under my screen here. So fluorine is a halogen as well. The halogens are known for being very reactive as well. So fluorine and chlorine especially are very reactive. They're found in nature. Fluorine and chlorine are found in nature as diatomic gases. Bromine and iodine are solid and liquid at room temperature. They react with metals to make salts. So I don't just mean table salt, sodium chloride, which you would eat with your food, but things like potassium iodide, sodium fluoride. Those are all things that are salts as well. And they have 7 valence electrons at an oxidation state of -1. Then finally, we have our noble gases down here on the end. I have mine done in gray. They include helium. They make up group 18, and they're very non-reactive and very, very stable. They don't tend to react with anything at all. They're used in neon signs. Neon signs get their name from neon, but not all neon signs contain neon. All but helium have 8 valence electrons. Helium only has 2 valence electrons, and they all have an oxidation state of 0. Last, down here on the bottoms, we have the lanthanides and actinides. The lanthanides are in pink, and the actinides are in brown. And if we had inserted these lanthanides and actinides into the table would be twice as long, so we tend to pull them out and leave them down below. They make up the bottom 2 rows of the periodic table, and we tend to see them detached. They're radioactive for the most part, and they're not often found in nature at all. And I don't personally use them in my chemistry courses very much. That's all that you really need to know about the lanthanides and actinides.